Welcome to Ctrl+Create's image manipulation process. In this video, our group will show you the process of doing an inverting effect in an image using a programming language called Python. Before you start processing your image, you must first install Python, 3 necessary libraries, and a code editor like Visual Studio Code for a smoother process. To install the libraries, use the command pip install numpy, pillow, matplotlib, in the terminal, which is already installed in your laptop or computer. To start, open your code editor and first create a folder for easier access. Then, create a Python script file by naming it and adding .py to the end of the file. You can also transfer your chosen image in the same directory. Once you have created the file, you can now import the code and its libraries. This will help in terms of handling the images as numerical data and displaying them on the screen. NumPy, PIL, and matplotlib.pyplot are the libraries that we will be using. NumPy is for numerical operations and array manipulation. Python, imaging library, or PIL is for image processing, and the matplotlib.pyplot will be utilized for data visualization. After importing the libraries, we will now start on manipulating the images. First, to input the image in the code, use the image_path equals empty string, and inside the quotation marks, enter the file name and do not forget to add the file format like .jpeg or .png. Then, we must also open the image and convert it into an RGB color model to ensure a consistent color format when processing the image. After converting, we will now convert the image again to a NumPy array to represent the image as a grid of numbers. At this part of the code structure, we are going to show the composition details of the images by using print in the code. The shape element seen in this point displays the height, width, and the amount of color channels of the image. The following code, which is the image_array, obtains the original or first pixel located on the top left corner of the image grid. To note, in every pixel, there are 3 corresponding color values present, which are the red, green, and blue, or known as the RGB. Meanwhile, at this juncture, we are going to make a big change in the manipulation process of the image. This line focuses on performing a pixel-wise operation, wherein each pixel's value is subtracted from 255 that will result in a negative or inverted image effect. The RGB color values range from 0 represents black, while 255 which displays a white color. Therefore, this process an inverting effect. Today, the colors of the image in which the dark values now become light and vice versa. In order to display the images properly, this code will be utilized to create a canvas. The canvas wouldn't be complete without the dimension or the output size. Hence, the fixed size attribute will be employed. In connection with the previous code statement, this two-part structure will be used to display the images inside the canvas. The first part focuses on displaying the original picture. The subplot function will locate the image in the canvas, while the amshow function will display the image. You can also add a text to indicate the name of the image by using the title element and the axis of. Eliminates any axis lines in the image. Subsequently, we are going to focus on presenting the resulting image from the manipulation process. This has similar code structure, but in this part, we are going to use the inverted image. Therefore, there are slight differences in the variable used since we are displaying the inverted image. As for the final step, we will now exhibit everything that we manipulated in the images and inside the canvas by using the code plt.show. How to run the code. To run the code that we made, and if you are using a code editor, open the terminal, and once you see a prompt in the first terminal line, put Python, your file name, and format and press enter. Once you enter the code, it will print the details in the terminal and present the visualization of the images through your screens. Everything should appear within a few seconds. Inside the canvas, demonstrate the comparison between two images. On the left, we are seeing the original image and there are no changes made. And on the right side is the result of the magic manipulation through Python. The color values in every pixel are inverted in the image once we convert the image into grid of numbers. The inversion is the result of subtracting 255 to every RGB color channel. As you can see, the light colors become dark while the dark colors showcase the light color value, resulting in a negative effect. This shows that digital images are not just pictures, but numerical data that can be manipulated mathematically. That concludes our presentation. We are Ctrl+Create, and this is how creativity meets technology through Python image manipulation. Thank you for watching.